Hello. In this video, we will talk about power analysis for correlations using R. So what is the power analysis? Power analysis allows you to determine how many the sample size required to detect an effect. So if we look at this figure, it is the basic idea for the power analysis. So there are four elements. First is effect size. So this is discipline related element. For example, ANOVA and linear regression and correlations, they have different meaning for the effect size. And this is the sample size. And for example, for ANOVA, this means the total sample size for all the group treatments. And this is significance level. This is for the test, for the type 1 error in the test. So which means if there is no such effect existent, but we reject it and we say there is an effect. So this is an error. And usually we want to make this type of error as low as possible. So usually set significance level at 0.05. Or we say this alpha is 0.05. So we will make this error as low as possible. This is for the wrong rejection. So actually the effect is not significant, but we say it is significant. So this is type 1 error. And the last part is for the power. So power, which means if the effect is existent and we also test it, we find it, we reject the null hypothesis. Null hypothesis usually say there is no such effect in hypothesis testing, and we find actually there is such kind of effect and we find it, we reject the null hypothesis. So this is the power. And actually power is 1 minus the type 2 error. So type 2 error is actually the effect is significant, but we did not reject it, and we did not find this effect. Actually, it is, right? So this is the power for the test. And usually the power test of the test 0.8, 0.9, and depending on different test discipline. And usually the power test of the test 0.8, 0.9, and depending on different test discipline. So if we know 3 of these 4, then we can get last one. So this is for the power analysis. And in R, for example, if we want to apply the power analysis for the correlation test. So correlation, which means the linear relationship between 2 variables, right? So if we want to say the correlations is 0.1 between these variables, so this is effect size. And we can set significance level and power, and alternative is for the 1 side or 2 side of the test. Then we can get how many samples we want to need to test such kind of effect. And the function is same as another is for the power R test. Power R test. So this is the package is for called PWR. You have to install this in R. So next we show an example. So let's assume that you are studying the relationship between depression and loneliness. So these are 2 variables. And you set the research hypothesis. Null hypothesis H0 is rho less than or equal to 0.25. And alternative hypothesis H1 is rho larger than 0.25. So this is the 1 side test, right? And the question is how many observations you will need to get such kind of effect in hypothesis testing for the correlations. And here As usual, we set significance level is 0.05, and we want to 90% confident that you will reject H0 if it is false. So this is the power 90%, because it actually the null hypothesis is false, and you also successfully reject it. So this is the power of the test. So here the significance level is 0.05 and power is 90%. And the question is, we want to calculate how many observations we at least have in such kind of test experiment planning. So we go to RStudio. So it's quite easy in RStudio. First, we load this package called PWR. Then we use PWR test and significance level are 0.25 and significance, this here effect size is 0.25 and significance level 0.05 and the power is 0.90, and with alternative is greater because here H1, the alternative hypothesis is greater. So this is one side test that we run. So the result is also very easy to check. Here listed all items in the power tests. So power, significance level, effect size, and alternative greater. Then we can see 133 in sample size. So here we need paired sample for a sample size 134 at least. Then for each sample we get the values for these two variables. Then you can find these correlations effect significant or not, and controlling with the significance level 0.05, and we can 90% confident if these correlations larger than 0.25, and we can find this. We can reject the null hypothesis that these correlations less than 0.25. And at the same time, we make the type 1 error as low as 0.05. Thanks for watching.